Have you ever really stopped to think about what truly separates us from every other animal on this planet? It's not just our big brains or our fancy tools. It's something we do every single day, most of the time without even thinking about it. We cook. We're going to dive into this radical idea that grabbing control of fire to cook our food wasn't just a nice little cultural step up, it was maybe the single most important event in our entire human evolution.
So let's start right there, with the big question. Why us? Out of the millions of species on Earth, how come we're the only ones who figured out how to use fire to make our meals? I mean, our closest relatives, chimpanzees, they spend hours a day finding and eating raw food, but they never cook. No other animal does. And this isn't just some minor little habit, it's a huge evolutionary mystery.
And the answer, as it turns out, has almost nothing to do with making food taste better. It's way, way more fundamental than that. For us, cooking is a biological imperative. See, we don't just cook because we like to, we cook because we literally have to. It's the secret to how our bodies, our brains, and even our societies came to be. Okay, so to really get why cooking is so vital, we first need to look at what happens when we don't cook. And this brings up a real paradox. If our ancient ancestors ate raw food for millions of years, why can't we just go back to that diet and thrive today? Well, for starters, just think about the time involved. Chimpanzees, our cousins, can spend up to 6 hours a day just chewing. We, on the other hand, spend less than an hour. And that huge difference? That is no accident. It's a direct result of cooking, which basically does a lot of the work of digestion for us before the food even hits our mouths. So what happens when modern people, like us, try to go back to an all-raw diet? Well, you hear a lot about it, but the biological evidence is pretty clear. Our bodies pay a really heavy price. We are just not the same creatures that we were millions of years ago. Our biology has been completely rewired, and it's now fundamentally dependent on cooked food.
And we've got the data to back this up. The Gissen Raw Food Study, which is one of the biggest on this topic, found that people who switched to a raw diet lost on average over 24 pounds. And this wasn't healthy, planned weight loss. It was a clear sign of what's called chronic energy deficit. Their bodies just weren't getting enough fuel.
In fact, the energy shortage was so severe that it started to shut down the most fundamental biological process of all, reproduction. A full half of the women in the study who were on a completely raw diet stopped menstruating. From an evolutionary point of view, any diet that brings reproduction to a halt is, well, it's a complete dead end.
And this isn't just something we see in modern studies. History is full of these tragic accounts of people trying to survive on raw, wild food. The explorer William Wills wrote these words back in 1861, right before he died on an expedition in Australia. He had an appetite, he was eating, but his body just couldn't pull enough energy out of the uncooked food. He was literally starving on a full stomach.
So, if our bodies are so badly built for raw food now, how did our ancestors solve this huge energy problem? Well, they harnessed the flame. You can think of cooking as a kind of external stomach, doing all the hard work of breaking down food before it ever entered our bodies.
So here's basically how that works. Heat completely changes the chemistry of food. It causes proteins to uncoil and loosen up, which makes them way easier for our digestive enzymes to attack. It also softens tough plant fibers and makes starches digestible. All this pre-digestion means our bodies use up way less energy to get much, much more energy out of the exact same piece of food. The result is a massive net gain in calories. And this isn't just a theory, we've actually seen this happen in the lab. Researchers fed Burmese pythons either raw or cooked meat, and then they measured how much energy the snakes used for digestion. And the results were amazing. The pythons that ate cooked meat used almost 13% less energy. For our ancestors, saving that much energy every single day would have been absolutely revolutionary. So what did our ancestors do with all this extra, easy-to-get energy? They invested it. This surplus from cooked food didn't just make them stronger. It became the fuel for one of the most important trade-offs in the history of evolution. It all comes down to something called the expensive tissue hypothesis. The basic idea is that your body has a limited energy budget. It can only support so much expensive, energy-hungry tissue. You can't have a giant digestive system and a giant brain, because both of them are massive energy hogs. To grow one, you pretty much have to shrink the other. And when you look at the fossil record, this is exactly what you see. Our earlier ancestor, Australopithecus, had this wide, flared-out rib cage to hold a massive gut needed to digest tough, raw plants. But then you look at Homo erectus, who shows up after we think cooking started, and you see a narrow chest, a smaller gut,
and a much bigger brain. Cooking let us trade gut tissue for brain tissue. And this change happened really fast, evolutionarily speaking. Around 2.6 million years ago, we see the first stone tools for cutting up meat. Then, by 1.8 million years ago, Homo erectus is on the scene, with an anatomy that's clearly built for a whole new kind of diet. Their teeth are smaller, their jaws are weaker. They just weren't built for hours of chewing anymore. They were built for soft, energy-rich, cooked food. But this whole revolution wasn't just happening inside our bodies. The control of fire and the daily ritual of cooking, it completely remade our social lives. The campfire didn't just warm us up, it forged a whole new kind of human society. I mean, just think about the ripple effects. Suddenly, fire gave you protection from predators at night so you could sleep on the ground safely. The hearth became the first community center, right? A place to gather, share food, and share stories. All those hours saved from chewing were now free for making better tools, for exploring, for developing culture. And really critically, the act of protecting and sharing a cooked meal became the foundation for partnerships and family, changing our entire social fabric forever. So, when you put this all together, you realize our relationship with fire isn't just some quaint cultural habit. It's baked right into our DNA. It is a biological inheritance that defines who we are. We are, quite literally, creatures of the flame. Now, this whole idea we've been exploring, it has a name, the cooking hypothesis. And it simply states that we are a species that is biologically adapted to eating cooked food, and that this one adaptation wasn't just some small change. It was the main engine that drove the evolution of our small guts, our big brains, and our incredibly complex societies.
The anthropologist Richard Wrangham, who is really the main champion of this idea, he put it perfectly. He said, "We humans are the cooking apes, the creatures of the flame." It just perfectly captures this deep, elemental link between our species and the fire that made us.
And all of this whole evolutionary journey, it leaves us with a really big question for our time. Our bodies spent millions of years evolving to thrive on simple, whole-cooked foods. But today, we live in a world filled with ultra-processed foods that are softer and more packed with energy than anything our ancestors could have ever dreamed of. So, if cooking made us human, what will this new food world make us into next?